Hi everyone, today we'll be going over titration curves. Okay, so it's kind of complicated, but I'll do my best to explain it. First we have a burette, and we have a beaker. So the burette is going to have a solution of a known concentration. So let's say we have 0.2 molar sodium hydroxide. And the beaker is going to have whatchamacallit, a solution of unknown concentration, so mystery molar hydrofluoric acid. So what's going to happen is that we're going to keep dripping sodium hydroxide into the HF, okay? And before we start any of this, we're going to use a pH indicator. And what pH indicators do is that they change color when a certain pH is reached. Okay? So when the sodium hydroxide neutralizes all the hydrofluoric acid, the solution in the beaker is going to change color because of the pH indicator. And then from that we can figure out how much, and the burette will tell us how much sodium hydroxide we needed. And then through simple Stokes geometry, we can find out the concentration of the hydrofluoric acid by finding out by simply doing some multiplication, just using simple multiplication. So yeah, I know. Okay, so let's go over titration curves. It's just a plot of the pH of the solution of unknown concentration as a function of the titrant added. So initially, in my example with the hydrofluoric acid and sodium hydroxide, it starts off with a low pH because I didn't add any base, right? So low pH, but after I add some base, it gets higher and higher until it reaches the equivalence point. And the equivalence point is when exactly enough base has been added to neutralize all the acid. Okay? And the half equivalence point is reached when enough base has been added to neutralize half of the acid into conjugate base. And this has an interesting property because at this point pH would be equal to pKa, and a lot, they ask this a lot on tests, I'll just tell you that. Okay, so there are 4 types of concentration curves or titration curves. And yeah, so what you can do a strong acid titrated with a strong base. So how would you draw this? Yeah, this could show up on a multiple choice where they'll ask you what kind of titration is it. Well, anyway, let's do this. Well, it's going to start off with a low pH because it's a strong acid, right? But as base is added, it's going to increase till it reaches equivalence point, and then it's going to go like that. And I know, I'm sorry, I'm a really bad drawer. And the pH at the equivalence point, that's going to be 7 because the strong acid is going to completely neutralize the strong base. And for strong base titrated with strong acid, it's the same thing, except it's reflected because you start off with a high pH and it goes down when you add the acid. And once again, at the equivalence point, pH is going to equal to 7. Yeah, so weak acids titrated with strong base, well, it's going to be a little different. This time around, you're going to have a buffer region between the start and the equivalence point, and that's because of the presence of a conjugate acid-base mixture. So, yeah, it's going to have a buffer region which pH doesn't really change at all. But then once you reach the equivalence point, boom, it's going to skyrocket, and it's going to go off like this. Ooh, sorry, I didn't really draw that well. Once again, I'm sorry. Also, let's say the equivalence point is right here. Now the pH is going to be above 7 because you have a strong base and a weak acid. So who's going to win? Strong base, obviously. So it's going to be more base. So that's why you're going to have a pH higher than 7 at the equivalence point. Yeah, so it's the exact same thing for the base, except it's a mirror reflection. So once again, you're going to have a buffer region. And then it's going to go down a lot after you pass the buffer region. And it's going to do that. And this time around, the pH is going to be less than 7 at the equivalence points because it's a weak base versus a strong acid. So, the solution is going to be more acidic, hence the lower pH. So yeah, just remember that with the weak acid titrations, you have buffer zones, and that for the strong ones, for the strong titrations, the pH is always going to equal 7, and yeah, so that's all you have to remember. Next video we'll go over the calculations, which can be really tiring. So see you later, and have a nice day.